Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, from the chapter of Refraction of Light, I would like to teach when the object is in denser medium and observer is in rarer medium, how the object appears in the denser medium. Like the same way, if the observer is in the denser medium and the object is in the rarer medium, in what way it appears, that is we discuss that. So these are very important for the very short answer type questions. Number of times, so based on this type of one, they are asking the question for 1 mark in this chapter. Object in denser medium and observer in rarer medium. This is our topic. Object in denser medium and observer in rarer medium. Yesterday, in the concept of vertical shift, I clearly explained. Same thing also discussed here on. So object is here. This is the initial position of the object. This is we can say as a O. From this one ray will be fall onto the refracting surface of the water normally. This is the point A, it is the N. We can say that. Now another ray will be fall obliquely onto the refracting surface. It is the point B. It is the N dash. It is the M. We can say that. Now this ray will be due to the refraction deviated. Here we can set the observer. Like this we can set that. So here we are observing that it is the observer's eye. Okay, observer in which medium? Rarer medium. Here O is the object. It is in which medium? Denser medium. Here observe very carefully. So what is our concept? Object in denser medium and observer in rarer medium. So that's why now here according to the diagram, so observer is in the which medium? Rarer medium is nothing but in the air, and object is in the denser medium is nothing but water. Now here, okay, so due to the refraction, what will happen? The light means the image of this one is applied to here. So that's why means initially the initial position of the object is at O, but after filling with water, if the observer was trying to see that one, the observer was seeing the object not at the O, he is seen at the which point? I point. I is the virtual image. That's why here, okay, what we are observing that one means when the object is in denser medium and observer is in the rarer medium, at that time the object appears shorter than the actual one. Means it is the height, we can say that this much of height of the object, it will be very comes to the towards which one? Refracting surface. That's why so the height of the object when compared to the initial, it is appears to shorter when the observer is in the rarer and the object is in the denser, like because of this is the height, we can consider that from this much of height it will become like this one. So here to here we can say that it is the h naught, height of the object or depth of the object from this. But here what we are observing that from here to here this point. So h height. That's why height of the image is smaller than the height of the object it is why it will be happen due to the refraction only. That's why what you are observing, that means in this one, in this case, object appears smaller than the actual. It is very important. So when the object is in denser medium and observer in rarer medium, at that time object appears smaller than the actual. It is actual, it is the appeared position, means near to the refracting surface. That's why object is appeared in the denser medium. In the view of observer, it is appears to shorter. You are observing that when you can stand in a water, our legs will be appears to, for example, our legs will be inside the water. At that time, when you can see our legs, the legs are appears to very short. Why it is short? Because of due to the refraction only. Next one, object in rarer medium and observer in denser medium. Here we consider one object is there here. Nothing was standing on that one. So this is the position of the object O. This height is h0. Now from this object we consider one ray will be from the object one ray will be fall normally to the refracting surface of the water. That's why it will be without deviation, it will be goes to inside. That is known. Another ray will be fall onto the refracting surface obliquely. That's why we know that when light will be travel from rarer to denser medium, it is deviate from their path and moves towards the like this. Now, but here we are observing that this is the first refracted ray, it is the second refracted ray. After the refraction from the refracting surface, these two rays are never meet, but where this object image will be found. That's why the first refracted ray produced backward and second one is also produced backward. Where the two are meet, at that point what will be found? Image will be found. That's why at point I, image will be found. Hi. So in this one, here we can see as a fish is there in this one, in the view of fish. Like this, we are observing that. That's why here the fish is inside the water. The fish we can say as an observer. Observer is in the inside the water, and object is in where? In the it is the O. It is in rarer medium. So that's why object is in the rarer medium and observer is in the observer. Observer is in the denser medium. During such condition, so the object is appears taller than the actual. Listen very carefully. It is the height of the object actually, but when an observer will be observed the position of the object in the rarer medium from denser to rarer, so it is not appeared here, it is appeared to taller. That's why object is appeared taller than the actual. So object in then rarer medium and observer in denser medium. The object is always appeared taller than the actual. What is the reason? Due to the refraction mode. That's why this is the height of the object from the refracting surface. This is the position of the image formed due to the refraction. That's why the height of the image is greater than the height of the object. In previous one, height of the object is greater than the height of the image, or height of the image is lesser than the height of the object. That's why when the object is in rarer medium, if object is in the denser medium and observer is in the rarer medium, at that time object is appears smaller than the actual. But if object is in the rarer medium and the observer is in the denser medium, at that time object is appears taller than the actual. Next we discussed about what is critical angle. What is critical angle? When light travels from denser medium to rarer medium at a particular angle of incidence, the angle of refraction becomes 90 degrees and grazes or touches to the surface of the refracting surface. That angle of incidence in the denser medium we are called critical angle. Listen very carefully. So critical angle, when it is possible, means light must be travel from denser to rarer. If light is travel from denser medium to rarer medium, at one particular angle of incidence, what we are observing, that angle of refraction in the rarer medium becomes to 90 degrees. At that time we are observing that the refracted ray touches to the surface of the refracting surface or grazes to the arc passing through along the refracting surface. That angle of incidence we are called critical angle. It is denoted by the symbol of angle C. It is a refracting surface. S dash is a refracting surface. We consider it is the rarer medium. It is nothing but air. We consider it is the water. It is the denser medium. Just for understanding now. So light travel from where to where? Denser medium to rarer medium. For this one, N, O, N dash. N dash is the normal for S dash. Now here we can say that, okay, initially angle I. This is the incident ray. The angle between incident ray and the normal is called angle of incident. According to this one, light travel from where to where? Denser medium to rarer medium. Because of critical angle concept, must be we can say when light travel from denser to rarer, but not from rarer to denser. It is not possible. Why? Also I will explain later in this video. So light is the travel from denser medium to rarer medium. In this one, just I will give one small example for you, but these values are not constant or practical values, just for assumption values. What means, you know that when light travel from denser medium to rarer medium, the light is deviate from its path and move away from the normal. Is it correct or not? That's why this is the initial path of the incident ray. But the light is not going to like this, the light will be travel like this one. So this is called, what is that one? Angle of refraction. So means when light travels from denser to rarer, angle of refraction is always greater than the angle of incidence. If for example, angle of incidence is 30, just it is we can say as 60, just for understanding of you. It is not exact values, just. So generally what we know that means, for example, according to the refraction process, when the light will be fall here, when the light will be fall onto the any refracting surface, some part of the light will be enter into the same medium, that is called reflection, and some part of the light will be enter into the denser medium, that is called refraction. Okay, so means when the light will be fall onto the surface of the water, for example, if you can see one aquarium in a glass chamber, it is the water, here fishes are there. So means if you can see in vertical downward, okay, we can see the surface of the water in the aquarium. Yes, because of how we can see the surface of the water in the aquarium. If the light will be fall like this one, that light here, you are the observer. So some part of the light, when the light will be fall onto the aquarium outer surface, some part of the light will be reflected by the surface. So that is the reflection. By the reflection, the light is reaches to you, then you can see which one. Surface of the aquarium. Now by the refraction, the light will be enter into which one? Inside the water. After fall onto the fishes, again come outside and reaches. That's why. So when you can see the fishes or anything in the aquarium, what will happen? By the reflection process, we can see the outer surface of the aquarium, and due to the refraction, we can see the inside the objects or inside the things only. That's why. So when the light will be fall onto any refracting surface, a few percentage of the light will be reflected and the remaining part will be refracted. For example, just for understanding of you, 15% of light will be reflected. If 100% of light will be fall onto the refracting surface, 15% will be reflected. Remaining how much one is there? 85% is refracted. That's why what I am understanding that how much amount of light will be fall onto the refracting surface, total light is not enter into the denser, only few percent will be enter, remaining will be refracted. That is meaning of that. Now here is also when light travel from denser medium to rarer medium, so 100% of light will be fall on refracting surface S dash. At that time, some part will be refracted, that is, you know that some part will be reflected. So how much percentage? 15%. Like this one you can say. Remaining how much percentage? 85% is refracted. Next, angle of incident is increased. Next case. Angle of incident is, for example, here 40. So angle of refraction is maybe this one. Angle R is equals to 70 degrees. Are you understanding or not? Okay, here 35 we can choose it. Angle I is 30, angle I is 35, it is the 70. Angle I is 40, it is 80. Angle I is 50, just for understanding, not exact values, it is the 90. But it is not, because of the critical angle of what is 48.5 or 48.6. So now I will be trying to explain simply. N O N dash S dash is the refracting surface. First, angle I is equals to 10 degrees. Just consider that. Angle R is equals to 60 degrees. Just more simply. Angle I, angle R, we can say that in this one. Angle I is 10, angle R is 60 degrees. Angle I is 20, 70, 30, 80, 40, 90. So means here angle of incident is increases, angle of refraction is also increases, because of angle of refraction is always greater than the angle of incidence. So when light travels from denser to rarer, that's why it is the denser medium, it is the rarer medium. But at the same way, I says that during the refraction, what will be happen? I says that when the light will be fall onto the refracting surface, either light travels from rarer to denser or denser to rarer. Some part of the light will be reflected by the surface and some part of the light will be entered into the other medium. That's why the part of the light reflected from the refracting surface, that is called reflection or reflected ray, and the part of the light is entered into the other medium, that is called refracted ray or refracted. So that's why here some part of the light will be entered to here. How much one? I say that 15%. How much one here? 85%. That's why just these are assumption values. When the light is travel from rarer to denser or denser to rarer, 15% of light will be reflected and 85% of light will be refracted. So means total light is not refracted, total light is not reflected during which one? Refraction. If angle of incident is 20, 70, 30, 80, 40, 90. 90 is nothing but here at this one. Okay, angle I is equals to 40 degrees. At that time, what is the angle of refraction? This is the refracted ray, because of, we know that the angle between refracted ray and normal is called angle of refraction. That's why. So the refracted ray is passing along the surface of the two media or touches to the surface of the separating of the two media or refracting surface. That's why at that time angle of critical angle is means angle of refraction is 90 degrees. So listen very carefully. When light travels from denser medium to rarer medium, at a particular angle of incident, the angle of refraction is becomes to 90 degrees, and the refracted ray is grazes to the surface or it is touches to the surface of the two media or refracting surface. This angle of incident we are called which one? Critical angle. Means angle 40 according to this one we are called as critical angle. Then after 40, what will be happen? If the angle of incident is, for example, 45 degrees or 41, then what will be happen? This light is enter. Means, so this refracted ray is also enter to here. Means, so when the incident light in the denser medium is greater than the critical angle, no part of the light is enter into the rarer medium, total light is enter into the the same medium is nothing but denser medium only. So already I says that. So when during the refraction 15% of light will be entered, okay, reflected, 85% is refracted. This is not exact values or practical values for assumption purpose only. But so when the angle of incident is greater than the critical angle, then what will be happen? So there is no refraction. The refracted is also entered into the same medium. That's right. So 15% already reflected, and this part is also entered. Means 85% is at the critical angle. 85% light is passing through the refracting surface. This 85% is also entered into the same medium. That's why 15% plus 85 total how much one? 100%. So 100% of light will be fall onto the refracting surface, 100% will be enter into the same medium. This is called TIR, total internal reflection. Means total light will be reflected back only without entering into the other medium. That is we discussed in the in the next video. But now we can discuss in that. So what is the critical angle when the light is travel from denser medium to rarer medium? The at a particular angle of incidence, the angle of refraction becomes to the 90 degrees. Okay, at that time the light ray is grazes to the refracting surface. That angle of incidence we are called critical angle. For example, if light travels from rarer to denser, is critical angle is possible? We discuss once again. It is the incident ray, rarer medium, denser medium. We know that when light travel from rarer to denser, it will be moves towards the normal after deviation. Means angle I is 10 degrees. Angle R is equals to 6.5. We know that. So angle I and angle R values you can see. 10, 6.5. Here decrease or increase maybe 10, 6.5, 20, 30, 30, 19.5, 40, okay, 26, 50, just you can say that, 32.5, 60, what will be happen? 32, 39, 38, 38, next 70, 44.5, next 80, 51, next 90, 57.5. So here we are observing that the angle of incident is when the light travel from rarer to denser, angle of incident is always greater than the angle of refraction, because of after the deviation the light is bends towards the normal, like that one 10, 6.5, 20, 30, vice versa. For the angle of incident is 90, so it is 57.5 only. So that's why what will be happen? Okay, after the angle I is 90, angle I is 90 means what is that one? The light ray is grazes, means the incident ray grazes to this one. At that one, refraction will be not possible because of no light will be refracted. So means the light, if the light will be fall normally, then what will be happen? It is undeviated. That's right. So when the light is travel from rarer medium to denser medium, the angle of refraction is not becomes to the 90 degrees. And no part of the light is not comes into the same medium. That's right. So light is travel from rarer to denser medium, critical angle and TIR is not possible. When it is possible, the light must be travel from denser medium to rarer medium only. So after the statement, you can draw this diagram for critical angle. N, O, N dash. Angle I, that is equals to angle C, 90 degrees. Angle R is equals to 90 degrees. So this diagram you can draw after write the definition of the critical angle. So light is travel from denser medium to rarer medium at a particular angle of incidence in the denser medium. The angle of refraction becomes to the 90 and the refracted ray is grazes to the refracting surface. What is the formula to find critical angle? That is we discussed that. According to Snell's law of refraction, we know that mu1 sin I is equals to mu2 sin R. From the diagram, we know that I is equals to C, angle I is equals to angle C, and angle R is equals to 90 degrees. Is it correct? So now in this one, which one you can find? We can find critical angle means that's right. So from this one, sin I is equals to mu2 upon mu1 sin R, because of this mu1 transfer to this side, mu2 upon mu1 sin R, that is we know that. Then sin I is equals to mu2 upon mu1 is nothing but we can write 1 by mu of 1 2. Is it correct? Because of we know that mu of 2 1 is equals to mu2 upon mu1. Mu of 2 1 is equals to 1 by mu of 1 2. Why I should write like this one means mu2 upon mu1 is nothing but it is nothing but mu of 2 1 means the refractive index of the second medium with respect to the first medium. Here air or vacuum we can say as a first medium and other medium we can say as a second medium. But light will travel from where to where? Second medium to first medium. That's why refractive index of the so means we want V of which one? V of 1 2. 1 2 is nothing but refractive index of the first medium with respect to the second medium. So generally air or vacuum we can say as the medium 1. Another medium we can say as a medium 2 when compared to the air or vacuum. But according to the critical angle, light will travel from second medium to first medium is nothing but what is the second medium? Air or vacuum is the first medium. That's why. So, but according to this one, this is represented which one? Refractive index of the second medium with respect to the first is nothing but light will travel from first to second. Is it correct? No, light is travel from second to first. That's why. So, what we can write? Is nothing but mu of 1 2. Mu of 1 2 is nothing but refractive index of the first medium with respect to the second is nothing but light travel from second medium to first medium. That's why. So what we can write that? Listen. So mu of mu2 by mu1 we can write mu of 2 1 and the sin R. Then sin I is equals to mu of 2 1 we can write 1 by mu of 1 2 sin R. So then sin I means sin C. Why? Because of angle I is equals to C, that is equals to sin R. R is nothing but 90 sin 90 upon mu. We can write. So here sin C is equals to sin 90 means 1 by mu. So this is the formula to find the critical angle. So sin C is equals to 1 by upon mu. Or that is we should be right like this one. C is equals to sin is transferred to that side. 1 by sin is nothing but sin inverse 1 upon mu. So this is the main formula to find which one? Critical angle. So critical angle C is equals to sin inverse 1 upon mu. So according to the Snell's law of refraction, we can find the critical angle formula, means you can derive the formula to find the critical angle. From the diagram, already we know that angle I is equals to angle C and angle R is 90. Sin I here in this one, mu1 sin I is equals to mu2 sin R. Mu1 transfer to the right hand side. Sin I is equals to mu2 upon mu1 into sin R. Mu2 upon mu1 we can write as a mu of 2 is nothing but refractive index of the second medium with respect to the first medium. But here light is travel from where to where? So where are denser to where are? So that's why refractive index of the first medium with respect to which one? First, second medium. Then sin I is equals to mu of 2 1. We can write 1 by mu of 1 2 because of refractive index of the first medium with respect to the second. It is nothing but refractive index of the air with respect to the water or other medium. Then sin R. Sin I is nothing but C. That's why sin C is equals to sin 90 upon mu. Sin C is equals to sin 90 is nothing but 1 upon mu. Then C is equals to sin transfer to the right hand side, it becomes the inverse, sin inverse 1 by mu. So that's why this is the formula to find critical angle. Now we discussed a simple numerical about the critical angle. The refractive index of the water is 4 by 3. Find its critical angle. Listen very carefully. So the refractive index of water or the refractive index of a medium is 4 by 3. Find its critical angle. So what is the formula? We know that sin C is equals to 1 by mu, or we can use C is equals to sin inverse 1 upon mu. Anyone you can use, either this one or that one. So they are given the refractive index of a medium is 4 by 3 and find its critical angle. So in this one we are using either this one or this one. Okay. C is equals to sin inverse 1 upon, what is that one? 4 by 3. It is brings to the numerator side. C is equals to sin inverse 3 by 4. Then C is equals to sin inverse 3 by 4 means 0, 0. That's why 0.75. So for this one, how we can find the value? So by using the logarithm table. So natural tangent, like that one is there. By using that in the logarithm table, for sine logarithm table we are using that sine inverse 0.75. So what is that one means? 48.7 degrees. This is the critical angle of water. Is nothing but, so in the light, when the light is travel from water to air, at that time the angle of incident in the water is 48.7. At that time the light ray is grazes to the refracting surface. If the light ray is more than this one, it will be total internal reflected. And this one we are also find out easily by using this one. Sin C is equals to 1 by 4 upon 3. Then sin C is equals to 3 by 4. Then sin C is equals to 3 by 4 is nothing but 0.75. So in the logarithm table, it is the inverse logarithm table, but in the natural sign, okay, in the logarithm table, natural sign is there. In the natural sign, for which angle, which natural sine angle, the value is 0.5. That is I will be showing laterally to you. So that is you can find. Here we can write sin C is equals to sine of 48.7. So means sine of 48.7 in the logarithm table in the natural sine the value is 0.75. Sine get cancelled, then c is equals to 48.7. That's why by using either that formula or this formula we can find easily. But using this one means you can use the natural sine table from the logarithm table. It is very easy. That's why. So either by the following either this method or this method you can find critical angle. This is the second method, that is the first method, or it is the first method, that is the second method. Any one formula you can use and solve the numerical based on this type of